Welcome to the screencast for the Scala programming language. Well, the screencast assumes that you already have gone through the first screencast of installing the Scala language. Now say you have been told to write a Scala program that makes the machine compute the area of a rectangle. Alright, so definitely you would be thinking on the lines of the instructions that you're going to give to the machine so that it computes the area of a rectangle. So you could well imagine that the instruction 1 of your program would be something that would probably say define the length of the rectangle. Okay, so that would be some length that you would define for the rectangle. Say the instruction 2 of your program would definitely be something on lines of defining the breadth of the rectangle. And yes, definitely after the 2 instructions have been done, the next instruction would be to make your computer actually compute the area of the rectangle. Now, if you have a look at these instructions, there is a clear requirement where the data, the data, when I say data, I mean the length and the breadth of the rectangle. The data needs to be referred to in instruction number 3 because it's only after that yes, you would be able to multiply the length and the breadth to compute the area of the rectangle. So in order to refer a data which you have defined in a particular instruction, at a later point in your instruction set, we go for something called as variables. We go for something called as variables. Variables are basically used to store data, and you can refer that data at a later point in the instruction set by just referring the variable. So now we can open the Scala interpreter to play with some variables, to play with the instruction set that I have defined over here, and see whether we can write these instructions on the Scala interpreter and whether we can refer the data that we defined in the first 2 instructions in the last instruction with the use of something called as variables. So we can open up the terminal. Once we open up the terminal, we can enter the Scala interpreter. Yes, so we enter the Scala interpreter. Now in the Scala interpreter, the first instruction that I need to probably give to the machine is to create a variable that will store the length of the rectangle. So how are we gonna create a variable that is going to store the length of the rectangle is where you need to just pause for a moment and probably ask yourself, is the variable that's going to store the length of the rectangle, are you going to modify that variable at a later point in the instruction set? Yes, at this point, this question that you need to ask yourself, you may feel very naive, as in, why am I asking this question? Why not just go create a variable and length, breadth, and why not compute the area of the rectangle? But believe me, as we go ahead, this question is going to be of utmost importance in your journey of Scala. So yes, we take a decision that the variable length that's going to store the length of the rectangle, I am not going to modify that variable, as in will there be a scenario that at a later point in your instruction you're going to give a different value to that variable, as in you're going to make that variable hold a different value. So as of now, yes, I do not think so that the variable length is going to hold a different value apart from the value that I give it now. So if you imagine your rectangle, say the length of the rectangle is 6. So how do I create a variable in Scala? Is I write the keyword val, I give a name to the variable, say length, equal to, I assign the value, say length of a rectangle is 6. I assign the value to that variable. Alright, so the variable length has been created, has been created. Now, the second instruction says to create a variable breadth. Again, I ask the same question: is breadth going to hold a different value at a later point in the program? For now, yes, it's a no. Breadth is not going to hold a different value at a later point in the program. Whatever breadth I give it now will be the value. Whatever value I give to the breadth will be the value that the breadth will have for the entire, you could say, the program life cycle. So I did write the keyword val and the name of the variable equal to the breadth. Say the breadth of the rectangle is, say, 3. Alright, the variable breadth gets created and it is storing the value 3, whereas the variable length is storing the value 6. Now, the third instruction says that I need to compute the area of the rectangle, which is basically I would be multiplying the length with the breadth. So, how can I refer a variable at a later point in my instruction set? Is by just writing the name of the variable. Okay, make note of the fact that do not end up doing something like this again, because you would end up redefining the variable. Here I want to refer a variable that has already been defined, so I write length into, again I want to refer the variable breadth, the value that the variable breadth stores, so I write the variable breadth over here. Definitely the area that it computes, I would want it to be stored in some another variable, because probably I would want to use the area at a later point in my instruction set. So again I ask myself a question: is the variable in which the area of the rectangle would be stored, am I going to modify that variable at a later point in the program? I'm not going to modify, so I write val and I write the name of the variable area in which I would want to store the computation of multiplying the length with the breadth. So val area equal to length into breadth, and alright, the interpreter already computes it for us, and it shows us that the value of area is 18. Now, so this was just a very simple program where we created a variable, and we even used that variable at a later point in the instruction set. Now, if you have a look at the value that the variable stores, it's a numeric value. To be more specific, it's an int value. Okay, so now it's definitely Scala is not limited to creating variables that can only store numeric values. I can have a variable val name which stores my name. Now, since my name is a textual data, is a data that has characters in it, I have to follow some syntax where I open a double quote, write my name, close the double quote, enter. Yes, I have created a variable name. Just in case you want to ask the interpreter the value that the variable name stores, you can just write name and the interpreter shouts at you that the name, the value that the name stores is Mehul. Now, definitely I can have variables that can store other kind of values. We saw a variable that stores an numeric integer value. We saw a variable that stores a textual value. We can even have a variable that can store a character, a single character. So say, what's your gender? So you would definitely say it's either M or F, rather than male or female, which would make it a string. So here in this case, yes, you could have gone ahead and stored a string value in the variable gender, but probably to be more optimized, since this is just a one character data, I would store it in a variable that stores character data, a single character data. So I follow the syntax. I start a single quote, write the single character, close the single quote, and alright, the variable gender now stores the value M. I can even have variables that can store numeric data with floating point decimals. As in, what's the value of pi? I want to have a variable that stores the value of pi. So 3.14, 3.14, just to the two decimal places. I press enter. Okay, so yeah, so it stores the value of pi. Okay, so which is 3.14. You can ask the interpreter. It echoes back to you the value of the variable pi. That's not limited to these many variables. I can even have a variable which says whether I can vote or no. Now definitely the value that this variable should store is something which is whether I can vote or whether I cannot vote. So which means you could have your own interpretation where you could say that if it has a value 1, which means the variable which means the person can vote, and if it has a value 0, the person cannot vote. So you could go ahead and do that. But since we have another provision where rather than giving it integer value, we can even give it a value which is, say, either true, or you can give it a value false, again optimized from the perspective of the memory. So for now, yes, you could say that I could give it a value that, say, can vote. I give it a value true, and the variable can vote is currently storing the value true over there. Now so these are the variables and the different type of values that it can hold. One thing that you would be seeing in whenever I have been creating variables is that the variable created has been getting some kind of type over here, as in the variable that I created over here got an int type, the variable that I created over here got a string type, the variable that I created over here got a char type, the variable over here had a double type, the variable over here had a boolean type. Now what are these? These are basically the data types. Okay, the data types, or they are often called as value data types in Scala. Okay, so just to name a few, we have the following value types in Scala. So we have a byte, we have a short, we have an I'm not going to get into that as of now. We have an int, which we just saw, we have a long, we have a float, we have a double, which we saw, value type, data type, as in it tells what's the type, what's the data type of the data that the variable is storing. We have a char, and yes, we even have a boolean, and we just saw a string data type that we have. So when we see these data types, it's basically these are the data types which define what kind of value can the variable store. Over here I would just want to we saw string. Okay, we saw string as the data type, but I would definitely want to keep it away from the so-called value data types in Scala. So, or rather, to make it more simple, for now we just call them as data types in Scala, and yes, I can include a string also in the data type in Scala. So definitely with this you would have observed that the Scala compiler, or the Scala system, based on the value that you give to the variable, it inferred the data type. So over here you gave a value m to the variable and it inferred the data type as char. Here you gave a value 3.14, it inferred the data type as double. Here you gave a value true, it inferred the data type of this variable as boolean. Now that was one way. The other way is where you be very much explicit or specific with regards to the data type that you want for your variable. Now without getting into too much of these, is definitely these variables differ from each other in terms of the you could say the amount of data that they can store, or the range of data that these variables can store. So if you could say that float basically, it stores around 32 bits of floating point decimal data, and your double stores around 64 bits of floating point data. That's only from the perspective of the amount of data that they can store, otherwise they do not have any difference. So say you want to be super optimized and you are like, no, I would want that pi should have a data type float, or say you want to be very very much specific with regards to that, you specifically want to say that length should, for some weird reason, should have a data type long. So for cases like these where you want to be very much explicit with regards to your data type that you want to give to your variable, Scala gives you a way to do that too, is where, say, if you create a variable val age, which is supposed to have only an int data type, you can explicitly define the data type of the variable by, after writing the name of the variable, you can write a colon, the data type name equal to the value. Alright, it creates a variable age, and the variable age has the data type that you explicitly gave over there. Let's practice one more. Is say you want to create again a variable, say your mobile number, okay, a variable that stores your mobile number, and you want it to have a data type long, because just for information, again, integer represents 32 bits of decimal data without floating point decimals, and long represents 64 bits of data that it can store. So you definitely you know that, and that's what I'm saying, is that the mobile number, which is a 10-digit number, does not fit in an int. So I would want to definitely have mobile with the data type long, so I write val mobile colon the data type, that is long, equal to whatever is your mobile number that you would want to give over there. So if we can just count it, 1 2 some random mobile number, and yes, we get an error. Now this is one thing where you got to be careful, is the number that you plan to store in the mobile variable of data type long. The number is treated by the Scala environment as an int type. So even before the assignment happens to this variable, the number is treated as an int type, and definitely this easily crosses the range of int. So if you see integer number too large, so it doesn't even come here. Here itself it infers that the number is too large. So in that case, we need to make a change, is you need to force the Scala, need to trick the Scala system to take this number itself as a number which is long. So you just write an L after that. Alright, your variable mobile gets created. On similar lines, say you want to store the value of pi, which is 3.14, and you feel that it's going to fit in float, and I do not need 64 bits of reservation in the memory. So you write colon the data type, that's float, equal to the value, and you get an error. So over here, another important thing that you need to remember is that when the Scala system sees the numeric data type with floating point decimal, it treats it as a double. Now you cannot assign a double to a float. You cannot assign that, because definitely double has a larger space as compared to float. Directly a double cannot be stored in a float. So in that case, you gotta make the Scala, you again gonna trick the Scala system to take this number with floating point decimal as only a floating point value, where you say that I know it should be a float and not a double. So again, you just write after the number the word f, and the Scala system starts treating the variable as a floating point value specifically over there. So yeah, so these are the the data types that you have. Again, you have your own choice, where you probably do not want to give a data type to a variable. You can go ahead with that. Probably there will be a case where you would want to give a data type to a variable. Probably here also there would be a case where you would want to give an explicit data type to a variable. Just in case, just it has its own set of advantages, I would say, because this way of giving an explicit data type to a variable makes the code much more clearer for people who see your code, and even for your co-workers. This is also fine, but again, sometimes if I'm taking, say, the value 6 from the user, of the program. In this case, I've just initialized the value 6, but if I'm taking the value 6 from the user of the program, there may be some ambiguity with regards to what would be the type of data that length would store specifically. Okay, so that's it for this screencast. Hope you enjoyed the screencast. Stay tuned for more. Thank you.